Good morning, students. Today's topic is method overriding. Now, see, what is method overriding? I just elaborate. Today's topic is method overriding. Fine. Now, this is the topic, and in Java or any object-oriented language, method overriding is one of the powerful concept. But remember, method overriding is only possible in case of inheritance. Without inheritance, method overriding never possible. In case of method overriding, the base class method override in the child class. When the base class method override in the child class, at that time, the method name same, return type of the method must be same, and the parameter must be same. This is the fundamental concept. So, method overriding without inheritance never possible. I can override the base class method in the child class. When I override the method name same, return type of the method must be same, and parameter of the method must be same. This is called as method overriding. But why we use method overriding, that is the next part we have to cover. See here, what is method overriding? I show you. Check here, I have a class that is class A. A is a class. Anyway, here there is a method called as public fine void, that is add. Add is a method. What type of argument I have to pass here? Take an example, int A, that is int P. Now, here you see that is the end of the method, end of the class. Now the question is what I tell? Overriding is only possible in inheritance. Without relation, method overriding never be possible. What is my next job? I have a class that is class B extends, that is A. See, without inheritance, overriding never possible. I can override the base class method where? In the child class. When I override the method, at that time, method name must be same. Parameter of the method must be same. Here you see int x, int y. Parameter of the method must be same. Return type of the method must be same. Return type must be same. Now, this is called as word. This is called as method overriding. So, now the question is, this is overriding. Now, why we override the method? That is the main concept, but it is the example of method overriding. This is the base class method. Here you see base class method. Base class method override in the child class. This is word, that is override. This method is override in child class. So this is the concept I already covered. Without relation, overriding never possible. Now, this is method overriding. But why we use method overriding? Now, next question is, as a programmer, why we use method overriding? Basically, there are two advantages are there. The first advantage is word. By the help of method overriding, programmer redefine the base class method in the child class. So what it tell? That is the first advantage is through method overriding. Here you see through method overriding. That is overriding. Programmer redefine the base class method in the child class. Overriding programmer, here you see programmer redefine, here you see redefine base class method in the child class. in the child class. Fine, in the child class. So without method overriding, it is not possible that as a programmer, I can redefine the base class method in the child class. In simple word, it is a technique through which, as a programmer, I can redefine the base class method in the child class. Take an example. I give you lots of situations where overriding is required. You know that Apple introduced the new model. When it introduced the new model, at that time, that is, the software must be changed. That is, the camera quality must be changed. Otherwise, that is, the high price never be charged. Security must be changed. So it can added some new security. It can added some new features in the new model. So people can afford the new model with a high price. So in this case, as a programmer, if I redefine the base class method in the child class, then that is possible. You know that if the child class, child class directly invoke the properties of word base class, but the child class also want to add some new property by the help of word method overriding. Now, this is the first advantage. Second advantage is word. It supports late binding. Fine. It supports late binding. Or it is called as runtime polymorphism. It is also called as runtime polymorphism. Here you see. Otherwise, runtime polymorphism is not supported. Are you getting my words? This is all about what advantage of that is what method overriding. But my question is, that is, what is late binding and what is runtime polymorphism? In case of Java, you know that whenever we call a method, compiler bind the method. But only one case, compiler unable to bind the method. The case is what? Method overriding. Because as the method name same, return type same, and parameter same, compiler treat them as a single method. So in this case, compiler unable to bind the method. As compiler unable to bind the method, after the object is created, in case of method overriding, after the object is created, JVM bind the method. When JVM bind the method, it is called as what? Late binding. But in most of the cases, when we call the method compiler bind, when compiler bind, it is called as early binding. Only one case, compiler unable to bind the method. What the case is? Method overriding. In case of method overriding, when we call the method, at that time, compiler unable to bind the method. At that time, JVM bind the method. When JVM bind the method, it is called as what? It is called as late binding. Now, I saw that most of the time, they ask you the question in the interview that, can you please justify that how it supports late binding? Because you are a developer. You have to justify this thing because it is a theoretical concept. You have to justify it programmatically. Now the question is, how can you justify it? I just show you a simple example. But when I move to the programming part, I must briefing it. See here, that is, I have a class. That is a fine class. That is A. A is a class. Now this class having an instance variable. That is int data. You know that data is an instance variable. When I construct the object of the A class, the size of the object depends on which variable? Instance. You already know that. Now here you see A having a constructor. It is what type of constructor? That is a non-parameterized constructor. Now, what the constructor did, it called the increment method. Here you see, it called the increment method. Anyway, the task is over. Here you see, Now I just show you what actually happens here. The task is over. What is my next job? I have to write here public void. What I did here, that is increment. When I call here, that is public void increment, I write here, that is data fine plus plus. Data plus plus. I just write here. Now A is a class having the increment method. Here the data is increased how many times? 1 times. I just have a class, that is a class, that is a B extends word. Here you see extends A. B inherit from which class? That is A class. Now check here. I have a constructor that is non-parameterized in the, that is B class. It also call which method? That is the increment method. Now that's the end of the block. Now here you see the method is override public void, that is increment. Here you see that is a increment method. Now I just override the base class method where? In the child class. That is method overriding. Now what I can did here, I just write data plus equal 5. Here what I write, data is equal to data plus 5. Anyway, that's the task is over. Now I just move to the calling part. See here. Now this is a box I just create. It is not programming. I just show you the example, then you understand what actually happens. I have a, that is word I write here, B A1 is equal to new B. What it mean? I am creating which class object? Child class object. Then what I write here, A1 dot, I just call, that is increment method. Now fine, what is my next job? I just write here, that is the fine system dot out dot, that is the println. But I can pass here A1 dot, that is data. I want to print the value of data. What it mean? How the memory is managed, I just elaborate. See here, when I write BA1, take an example, if it is a local reference A1, A1 occupy the memory from stack. Here you see A1 occupy the memory from stack area. When I call the constructor, that is the child class object is constructed. You know that the child class object must occupy the memory from the heap area. You know that the size of the object depends on which variable? Instance variable of child class and instance variable of base class. In the child class there is no instance variable is there, but in the base class there is an instance variable is there. What is that? Data. I am not initialized the data. It is initialized by 0. You know that it is the fundamental concept at the object creation time. If I am not initialized the instance variable, then it is auto initialized by JVM through the default value. If the base address of the object is 1059, take an example. It hold 1059. Take an example. I am just telling that take an example because memory management in case of Java is totally managed by JVM. Now what actually happens, I call the child class constructor. You know that. It is the rule of inheritance that every child class constructor must implicitly call base class constructor. When it call the base class constructor, I am calling the increment method. Now, anybody can tell that as it is the constructor of the base class, it must call the increment method of the base class. But no. It is the concept of method overriding. I override the method. And here, which class object is created? That is child class object is created. Here, who bind the method? Is the compiler bind or JVM bind? JVM bind. As the JVM bind the method, that is what JVM bind the child class method. Here you see JVM bind That is child class method. Child class method after the child class object is created. So what happens? Data value is 0. 0 plus 5 is 5. After the execution of the constructor is over, then it will back to the child class constructor. Because child class constructor call it. The child class constructor also call the increment method. When it call the increment method, same way. Here also, that is a JVM bind. That is a child class method. You know that as the child class object is constructed, JVM also bind what? Child class method. When JVM bind the child class method, 5 plus 5 is 10. After that, what happens? When it write A1 dot increment, A1 points to the child class object. That means that is what it called the child class increment method, because here also JVM bind, that is child class method. You know that this concept in Java is called as what? Lead binding. As here what happens? Who bind the method? Is the compiler bind or JVM bind it? JVM bind it. So it is called as early binding or late binding? Late. Then after that, what happens? 10 plus 5 is 15. What is my next job? System.out.println A1.data. What the data value is? Data value is what? 15. Now check here. This is the concept of what? Lead binding. If anybody asks you what actually lead binding is and who supports lead binding in Java, method overriding. Method overriding supports what? Lead binding. So a simple example. This is the example of what? Lead binding. Or runtime polymorphism, or it is called as dynamic polymorphism. Now, that is a restriction. Next topic is what are the restriction of method overriding? Here you see, there is a restriction of, that is a method overriding. Here you see, there is a restriction of method overriding. Now, what are the restriction? I have to cover one by one. What are the restriction? Then you understand. What are the restriction? The first restriction, here you see, that is a static method cannot be override. Static, here you see, method. Static method cannot be override. They ask you the question, can the main method override in Java? You tell, no. Main method cannot be override. Because main is what type of method? Static. Second one is, that is final method cannot be override. In case of Java, final method cannot be, here you see, override. Check here, final method cannot be override. Third, what the third one is? Private method in Java cannot be override. Here you see, there is a private method. Here you see, method in Java. That is cannot be override. Cannot be override. So these are very powerful point. You have to understand which method cannot be override. Now, I just show you a simple example. I have a class, that is class, that is X. X is a class. It has a static method. What I can do here, static void, that is call. Remember, call is a static method, and the static method in Java cannot be override. Next one is final. If I write here, final void, that is so. Remember, so is a method that cannot be override. The last one is private. Here you see, private void, that is fine. Fun. See here, the private method cannot be override. These are the questions they will ask you. Which method in Java cannot be override? This method cannot be override. If you did that, it generate what? Compile time error. See here, if I write class that is y extends that is x. Now y inherit from what? X. I just do one thing, void call. Now it directly generate what? It generate error, compile time error. Because as a programmer, I can't override the static method. If I write here, that is void so. Now it directly generates what? Compile time error. Why it's an error? Because the final method cannot be override. I want to write here void that is fun. That is a fun is a method that cannot be override. Remember, this method cannot be override because private property never be invoked outside the class. It never generate any error, but method cannot be override. So here you see fun method is not override. But it does not generate any error because private property never be invoked outside the class. Getting up to this extent, I covered what is the restriction of method overriding. Now, I move to the next part. Another feature is also there, or another restriction is there. What is the fourth restriction? When we override the method, either we override it by same as a specifier or least restrictive. What is the meaning of that? Take an example. I have a class that is a class A. A is a class. It has a method that is public. Here you see. There is a public void. That is fun. Fun is a method. So what Java tell? Java tell that when I override the method, I'm bound to override it by the same as a specifier or least restrictive. Now you see, I have another class, class B extends word, that is extends A. B is a class which is inherited from A. When I override, if my access specifier is public, I'm bound to override it by public. That is void. Here you see, that is fun. You are bound to override it by fun. That is public access specifier. Next one. If my access specifier is protected, here you see. If the access specifier is protected, careful. When I'm using my access specifier which is protected, either it is override by public or it is override by protected. Cleared? Now see, when I override the method, either it is override by public or by protected. If my access specifier is no access or default, here you see, either it is override by public or it is override by protected or it is override by, that is no access. Fine. Or override by no access. So careful, this is the concept that I covered. These are the restrictions that I covered. But Java also supports, that is a method overriding by a annotation. You see, there is a system defined annotation is there. What the system defined annotation name is? @override. So now JDK 1.5 tells that when we override the method, you have to instruct the compiler by an annotation that I want to override the base class method in the child class. Then it is the job of the compiler to match the signature. So as a programmer, I can specify my intention in front of the compiler by the help of annotation. Listen, annotation always starts from @ symbol. Override, O capital, here you see, when I write here, override, by the help of this annotation, I instruct the compiler that the base class method I want to override in the child class. So now it is that is a formality. As a programmer, I instruct the compiler by using annotation. So nowadays, you have to use word annotation. You know that annotation is of two types. When I move to the advanced area, I must elaborate. One is system-defined annotation. Another one is custom annotation or user-defined annotation. This is a system-defined annotation that is basically used for overriding. Now, nowadays, when we want to override the method, then we have to specify the compiler by using this annotation. Cleared? So that's all about the concept of word that is annotation. Now, another feature Java use. That feature is called as that is covariant return type. Here you see covariant return type. What actually it means, covariant return type? It is also a new feature introduced in Java. Basically, what happens in case of covariant return type, what happens? The return type may same or may not same. But you know that Java tell in case of method overriding, the return type must be same. But Java tell no. The covariant return type is a feature through which the return type can be different. But covariant return type is only applied when the return type is the reference of a class. Now, I just show you the example. Covariant return type tell that when I override the method, at that time return type can be child class reference. Now see what actually covariant return type is, then you understand. I just write here class, that is A. A is a class. Here you see, I just have a right here, public. That is what I can do here. You know that in case of Java, who is the base class for every class is, you know that the base class for every class is word, that is object. So I can write here object, that is get object. See here, get object. No issues are there. A return type is the reference of which class? Object class. Now here I return, that is return, that is fine. Java technocrat. Here I write Java technocrat. I write. No issues. I am returning a string object, but the return type is the object class reference. Now see, I just write here class B. That is extends, here I write A. I use the annotation @ override. What it indicate? As a programmer, I instruct the compiler that I want to override the base class method in the child class. Now, here it is, I can write like this, public string. That is fine. Here you write get object. See, here the return type is not same. Return type is different. But Java tell this is applied by the feature of word covariant return type. Here the base class method return type is base class reference, whereas when I override the method, the return type is the child class reference. It's not a problem. It's not an issue. I just write here, that is return. That is, I just write here, that is Rashmi. Anyway, that's the end of the block, end of this area. It's not an error. I am just I instruct the compiler that I want to override the method. Compiler match the signature. And it's not an error generated by the compiler because This feature is called as covariant fine return type. Return type. This is the concept. So fine, that's all about the concept of word method overriding. Thank you. I must elaborate everything through the lab class. Check here. That's all about the concept of word. That is the concept of method overriding. Thank you. Hi students, I already covered method overriding. I already covered the theoretical part of method overriding. I already told you that method overriding supports word runtime polymorphism. You already know that method overriding supports word runtime polymorphism. I already show you a simple example of method overriding. But now I practically justified everything. Check here. I write here, notepad. There it is, test1.java. See. I just show you some examples, then you understand what actually happens in case of Java. I write here, that is the class, that is base. Base is a class. Check here, I write a simple code, that is a class base. Here I write int data. You try to understand data is an instance variable of the base class. Now you see, base having a non-parameterized constructor. Within that, I just call increment method. See here, yet I am not defining the increment method in the base class. Check here. I just write here public, that is a public void, that is increment. This is the method. What I can do here, I just, that is word, write data plus plus. So the base class increment method increase the value of the data only one times. Now I just show you what is called as runtime polymorphism. That is my intention, and I already explained it diagrammatically. Now you see that is a class, that is a SOP extends base. Here you see I already covered. Method overriding is only possible in case of word child class. The base class method is override in the child class. I already covered that. Now you see what I can do. I already used the annotation at the rate override. I already covered in the theoretical part of that. I'm using annotation to instruct the compiler that the base class method is override in the child class. I just write here public void increment. Check here. What I can do here, data plus equal 5. In the override method, data increase how many times? So that is 5 times. Here you see sub having a constructor. What I can do here, that is I just write here increment method I call. End of the block, end of this area. What is my next job? I just write here public class name is test1. Here you see public find static void main. What I pass here string, that is args. We just enter into the main. Check here. Now see, it's a simple code I write. I already justified this program in the theoretical areas. I just write here sub ss is equal to new sub. You see what I can do here. I am calling the child class constructor. The child class object is constructed at the runtime. You know the rule. When I am calling the child class any constructor, it must implicitly call the base class which constructor? Non-parameterized. That is the concept of word. That is the concept of that is inheritance. When it called the base class non-parameterized constructor, the base class non-parameterized constructor called the increment method. Now I already covered increment method supports what runtime polymorphism. When the increment method is called, either implicitly or explicitly, JVM check which class object is constructed. Here I am constructing the child class object. So when I construct the child class object, JVM bind the child class method. So even if it is the constructor of the base class, it call the increment method which is override. When object is constructed, data is not initialized by me. So it is auto initialized by JVM by 0. Then when the override method called 0 plus 5 is 5. Then after the base class constructor job is over, it will back to the child class constructor because the child class constructor call it. Now the child class constructor also call increment method. For the same object, data value is 5. 5 plus 5 is 10. After that, what is my next job? S start increment. When I call S start increment, what actually happens here? That is, here you see. Another time I call the increment method. So compiler not bind the method, but JVM bind the method, which is override, because I am creating the child class object. Now, when override method is called, 10 plus 5 is what? 15. I just write here system.out.println. That is anyway data value, that is for the object is, data value for the object is, that is S start data. Check here, when I call S start data, it must print as per, that is my theoretical concept, it must print 15. If it print 15, then you blindly tell that it is the concept of word method overriding. So method overriding supports word runtime polymorphism. Cleared? Now you see, this is the example of word method overriding. I just compile the code Java C. Check here. Now Java, that is test 1. Check here. What is the value is 15. Now this concept in Java is called as word, that is runtime polymorphism. See, this concept in Java is called as runtime polymorphism. Cleared? Fine. Now, I already covered some restriction in case of word method overriding. First, when the method is private, then that method cannot be override. Check here. My method is a private method, then you must know that private method cannot be override in Java. I just do one thing, compile the code, error. Method doesn't override and implement a method from a super type. Because the method is private and the private method in Java cannot be override. Check here. Second, I just move here, I cut the private keyword, I make it word of final. You know that the final method cannot be override in the child class. See here, when the base class method is final, that method cannot be override. See, increment method in subclass cannot override increment method in base. Overridden method is final. Next one, I already covered. What the last? Next one is that is a static method cannot be override. Check here. I cut final. I make it word static. It directly generates word error. Why I make it a data is comment line? Because data is an instance variable, static method called the instance variable through object. That is the reason I make it a comment line, so it not generate any error. But as the method is static in base class, that method cannot be override. I just do one thing, compile the code, error. What the error is, overridden method is static. It directly generates word compile time error. Now check what I can do. Another restriction is there. What the restriction is? See, I cut the static keyword from here. I make it word public. Check here. I make it public. Now see, the override time, I'm not using here public. I make it word protected. Now Java tell that it is another restriction. When you override the base class method in the child class, either you override it by same as a specifier or least restrictive as a specifier. When my base class is public, I'm bound to override the method by public, because in case of Java, no other as a specifier is least restricted than public. Now you check, I compile the code, error. It is a weaker access privilege, was bound to be public. So I already covered whatever the concept I covered, the theoretical part I covered in case of method overriding. I justified everything by the help of word, by the help of that is program. Here you see, when the base class method is public, I'm bound to override it by public. Now error is solved. There are 4 restrictions are there. Private method of the base class cannot be override. Static method of the base class cannot be override. Final method of the base class cannot be override. If the base class method is public, it is bound to override by public. Otherwise, it generates compile time error. Now, I move to that is a second example. See here. Why I move to the next part or the second example, my intention is what I want to show you. What is the requirement of using annotation? Why I use annotation? I already covered annotation is introduced in JDK 1.4. The main purpose of annotation is as a programmer, I can instruct the compiler about the motif. Annotation is of 2 types. One is user-defined annotation. Another one is system-defined annotation. When I enter into reflection part, I show you how can you create your user-defined exception. User-defined annotation. Now, there is a annotation is used in case of method overriding. That annotation is @ override. You know that every annotation starts from @ symbol. I show you that what is the problem we'll face in case of overriding. Now take an example. The method name by mistake, it changed by capital and small letters, then compiler treat them as a different method. It never generate any error message. For example, here I am just showing you the same example. Here you check. I am not using any other example, then you understand what is the use of annotation. I cut this annotation, fine. What actually happens? I am cutting this annotation. Here increment I is small. Here by mistake I write I is capital. Method name same. But by mistake, it is a human error. That is I make the override method, that is the capital I, started from capital I. So what the compiler does here is the compiler treat them as a single method or 2 different method. That is 2 different method. Because in this case, compiler never give any error message. It never supports the runtime polymorphism. In this particular application, when I call the child class constructor, the child class constructor implicitly called the base class constructor. It called the increment method. As I is small, priority given to the base class method. Because method is not override, here compiler bind the method data plus plus. 0 plus plus is 1. After the base class constructor job is over, it will back to the child class constructor. It also called the increment method. When it called the increment method, I is small, same thing applied, call the base class method, 1 plus plus is 2. Now after that, when execution of the constructor is over, it move to the second line. It call assisted increment, find data plus plus 2 plus plus is 3. Here the data value is not 15, but data value is 3. But the question is it generating error? No. Because here the compiler never understand what is my motive, what is my requirement. Compiler not understand it. So it not generate any error message. Cleared? Now see here, what I can do, I just compile the code. I just execute the code. See here, what is my intention is, I just execute the code. What the value is 3. But it is not generate the error because compiler never understand my motive, my intention. Java tell this type of problem is avoided by using word, or this type of problem is solved by a annotation. What the annotation name is? At the rate override. When I use this annotation at the rate override, the compiler understand what is the motive of the programmer. The main motive of the programmer is what it wants to override the base class method of where? In the child class. But the method is not override in the child class. Here, the child class case, the method name is increment, but I is capital. Java tell I can solve these issues by the help of what? That is I small. When I make it small, then error is solved. If I make it capital, then blindly tell compiler generate error. The same program, I am not making any changes. Previous case, it does not generate any error. And it not supports what? Runtime polymorphism. It supports what? That is static polymorphism. But in this case, you check, when I use the annotation, directly generate an error. Now, what is the problem? How the problem is solved? Check here. The problem is solved by the help of, that is I is small. When I make the I is small, then the problem is solved. Clear? Check here. What I can do, compile the code. I just write here Java, that is test 1. Check here. What the value is? 15. So now you please tell me, when I override the method, is the annotation is required or not required? It must be required. As a programmer, I have to, that is word, override this method. When overriding is there, I have to use word, annotation. So it is recommended. You have to use annotation at the time of word method overriding. Now, I move to the next, the last feature. Another powerful feature is covariant return type. Now the questioning is, what is covariant return type in Java? Java tell that, or in object-oriented concept, it described that in case of method overriding, return type must be same. But covariant return type tells that in case of Java, return type can be different. How it is possible that I can explain that return type can be different? Java introduced a feature in JDK 1.4. That feature is called as covariant return type. Covariant return type is only applied when the return type is the reference of the class. And in that case, at the time of method overriding, return type can be same or can be the child class reference. Now, I just show you a simple example, then you understand what actually I want to explain. I write here notepad, that is text.java. I just write here. Now, what I can do here, I just write class, that is x is a class. That is public object, that is get name. I just write here, get name is a method. Here you see, return, or I write here, that is that is a system.out.println. What's I pass here? That is I am in base class. I am in the base class. Fine. Then I return here, that is Java Technocrat. Anyway, I just write here Java Technocrat. End of the block, end of this area. I just write here class Y extends word X. Y is the child class of which class? X class. I just use the annotation at the rate override. That is a public string. What's I passive? That is a get name. I just write. Would I write here system dot out dot println? What's I passive? That is I am in the, that is child class. I am in the child class. Anyway, I just write here return, that is Java technocrat. Now here you see, I am using here word, I am using here method overriding. I use the annotation. If the method is not override, then it must generate error. Get name is the method name, but the return type is not same. The return type is word different. In the base class method, the return type is object class reference, whereas in the override method, the return type is the string class reference. This is not possible in any object-oriented language. It is not possible, but Java tell possible. And this concept is possible in Java by the help of a concept called as. That is a covariant return type. Here you see variant return type. It is only applied when the return type is the reference of the class. It never be applied when the return type is void or any primitive data types. Now I just move to the next public fine. That is a class. What's I pass here? Text. Text is the class. What I can do here? Public fine static void. That is the main. What's I pass here? That is here you see string args. We just enter into the main. What I can do? YAA is equal to new Y. Here I just write a string name is equal to AA dot get name. No requirement of typecasting because I am creating the child class object. When I call get name, your compiler not bind the method, here the JVM bind the method. After the child class object is created, JVM bind the child class method. Return type is not object class reference, return type is string reference. Here I assign it to name. Name is of string type, no casting is required. Now check here, what I can do here, system dot out dot println. I just write here, that is name is plus name. Now check here, what I can do. I just ended the block. See, what I can do. I just ended the block. Over. This concept is called as covariant return type. I just show you some practical implementation of method overriding. Because in the interview you face this type of questions in case of Java. Java differ from other languages. You just check it. I warn that you must be practically strong or programmatically you must be strong. Because you are a developer. It is my request to every that is word students, those who are following my videos, it is requested that you please continue up to last. Otherwise, you are not able to grab the concept. We try to clear your fundamental concept, object-oriented concept. Then it is better if you grab this concept. You can easily grab Spring Boot. Now, I must elaborate the Spring Boot part also, but I want that you must be strong in the core part, then you can easily move to the Spring Boot elaboration part. Thank you. You check first what is the result, then I conclude it Java C. Now compile the code. This is not generate any error, you check. Now Java, that is text. See here. What did write? I am in the child class. So child class method is called. This is the concept. Thank you. That's all about the concept of word. That is what a method overriding. Thank you.